Hello, students. A very warm good morning to you. How are you doing today? I will be taking you through this particular topic, which is probability, and we're going to be looking at some of the elementary parts of it. And this will be the first part, and then we'll proceed as time goes by. So I want you to listen attentively and follow the class so that you can have a very good understanding of this topic. This topic is a very easy one, and if you're able to follow it, then you can answer any question at all that you come across on probability. The aim of the class is to let you know what probability is, to discuss with you about theoretical and experimental probabilities, how to get your sample space, and how you can get the probability of certain events using theoretical and experimental methods. Okay, so that's what we'll be dealing with basically in this class today. Alright, so we'll go right into it. Probability is a measure of how likely it is for an event to occur. It is the measure of the likelihood of an event. Okay, so if an event is very likely to happen, then the probability is high, and if an event is very unlikely to happen, the probability is low. You see, most times we cannot predict events with total certainty, so we only predict the chance of the occurrence of such an event, whether it is likely to happen or not. You see, you can't be sure using probability methods. You cannot ascertain whether something will happen or not, but of course you can predict the chance that event has of happening. So probability can range from 0 to 1, where 0 means that the event is an impossible one, and 1 indicates that the event is certain. Okay, for example, it is certain that there will be day and night. That's a certainty. Okay, so in such a case, the probability is 1. And then there are some events that you are sure cannot happen. The probability of such events is 0. So the probability of all the events in a sample space adds up to 1. So the probability of all events add up to 1 in a particular sample space. For example, today you're either in class or you're not in class. Okay, so it's certain that you're either here or not. That means that the probability is 1, because there's a certainty to the sum of those two events. Okay, but we'll go into that better as we proceed. Now, theoretical probability is based on the possibility of occurrence of an event. So when we're talking about theoretical probability, it's just a theoretical way of looking into the possibility of an occurrence. So it is mainly based on a reasoning. It is also reasoning that is this thing likely to happen or not, based on the theoretical evidences that we have. For example, if a coin is tossed, the theoretical probability of getting a head would be 1 out of 2. Why? Because there is only one head and 2 possible options. It could either be head or tail. So if you ask for the probability that it will be head, then there is one head out of 2 options. That's where you have 1 over 2. Of course, that would be 0.5. Okay, so that's how theoretical probability works. It's a prediction based on mathematical reasoning. And then you have the other part, which is experimental probability. Now, in experimental probability, you actually carry out the experiments. You actually throw the die, and then you are able to compute your result. So experimental probability is calculated based on the outcomes, okay, and the total number of trials. So you're just going to divide the number of outcomes by the number of trials. So you have to experiment in experimental probability. So if you toss a coin 10 times and the head comes up 6 times, then The experimental probability for head is 6/10, which of course you bring down to the lowest terms, which will be 3/5. Okay, but if it were to be a theoretical probability, then that would be 1/2 because an experiment was not conducted on it. Okay, so the entire possible set of outcomes of a random experiment is the sample space, or it's also called the individual space of that experiment. So there's what we call the sample space. For example, if you toss a coin, or you toss 3 coins at the same time, Now, the sample space, it's possible that the first coin and the second coin and the third coin return as a tail. Okay, it could be tail, tail, and tail. And then, of course, it could be tail, tail, and head. The first two comes up as tail, while the last one comes up as a head. And then it's possible for the first to be a tail, and the second to be a head, and the third to be a tail, and on like that, until all possibilities have been accounted for. That's what is called the sample space. The sample space is the set of every possible outcome of such an experiment, okay, of such probability. So suppose if we want to find only the outcomes which have at least 2 heads, so if we want to find the probability of outcomes that will have only 2 heads, then that would be, if you look at your sample space, only 2 heads, that would be CHH, that will count, right? You have 2 heads, HTH, that will count as well, and then you have HHT, that will count as well, and then you have HHH, which has a minimum of 2 heads. So you'll see that there are 4 possibilities. You have HTH, you have HHT, you have HHH, and THH. Now these are all the outcomes that have 2 heads in the minimum. So there are 4 of such, 1, 2, 3, 4, you can see that, divided by the total number of possible outcomes will give you the probability. Okay, but the possibilities are 4. So an event is a subset of the sample space. So an event cannot be outside the sample space, because the sample space carries all possible happenings. So anything that happens is within the sample space. Okay, now if we look at this, what is the probability of occurrence of an event? It will be that the number of favorable outcomes the number of favorable outcomes to the total number of outcomes is defined as the probability of occurrence of an event. So the probability that an event will occur is that number of favorable outcomes divided by the total number of outcomes. So if I want a head, I'll count how many outcomes give me the head that I want, and then I'll divide by the total number of outcomes in the case of a coin. You understand? Now let's see this table, which gives us a definition of an example of virtually some of the important terms that you would need to keep in mind when you are dealing with probability. The first is the sample space, and it is the set of all possible outcomes that can occur in any trial, just like we said. So the sample space for the toss of a single coin will be head and tail. Those are the 2 options that are possible. Okay, that would be the sample space. Is the set of all possible outcomes. For example, if you roll a die, then the sample space would be 1, 2, 3, 4, 5, and 6, because those are all the possibilities. Okay, so an example would be, okay, beautiful, tossing a coin, sample space is head and tail. Yeah, you have it right there. And then the second one is called the sample point. It is one of the possible results. So in a deck of cards, for example, you have 4 of hearts. That's a sample point. It is one of the possible returns. It's possible that if you draw a card, you could draw the 4 of hearts, okay, or the queen of clubs. That's a sample point, one of the possibilities of an event. And then you have experiment or trial, and in this case, an experiment is a series of actions where the outcomes are always uncertain. So when you're performing a probability experiment, you are unsure of what the result will be. Okay, just like you're throwing a coin, you are not sure whether it will be head or tail. Okay, or you're drawing a card, you are not sure. That's an experiment. And so selecting a card from a deck and throwing a die and things like that, And then we also have what we call an event. It is a single outcome of an experiment. So when something happens, it is an event. Okay, so most times we have to calculate the probability of an event or of a set of events. So if you get a head while you toss a coin, that is an event. Okay, that is an event. And then the next one is the outcome. That's the possible results of a trial. So it is possible for you to have a tail when you toss a coin. That's one of the possible outcomes. So it's called an outcome. And then when it actually happens, it's called an event. And then you also have complementary events. That is the non-happening events. That is, the complement of an event A is the event not A, or A prime, just like you have in your set theory, if you remember very well. Okay, A prime will be all events that are not in A but are in the universal set. Okay, so the universal set is just like the sample space here, and then when an event A happens, everything that could have happened but did not happen is called the complementary events to A. Okay, so now if you have a 52 card deck, then you draw a heart. Okay, then the opposite of that is that you didn't draw a heart. That would be your complementary event. And then lastly on this list, you have the impossible event, where the event cannot happen. Okay, in tossing a coin, it's an impossible event to get both the head and the tail at the same time. Okay, because one of them has to come out on top. Now let's look at a few examples and application of these things that we have read and heard so far. Number one example says there are 6 pillows in a bed. 3 are red, 2 are yellow, and 1 is blue. What is the probability of picking a yellow pillow? Now there are 6 pillows, so the answer, the probability is equal to the number of yellow pillows, because that's the favorable outcome. Remember, probability is number of favorable outcome divided by number of total possible outcomes. So we want a yellow pillow, and the number of favorable outcomes will be 2, because there are 2 yellow pillows out of a total of 6 pillows in the bed. Okay, so you just have the probability of yellow would be 2 over 6, which of course will bring to the lowest term, which will be 1 over 3. Okay, so that's quite easy. Let's look at the second question. It says there is a container full of colored bottles, red, blue, green, and orange. Some of the bottles are picked out and displaced. They are removed. And Shola did this 1,000 times and got the following results. So number of blue bottles that he picked out were 300. Number of red bottles picked out were 200. Number of green bottles picked out were 450. And number of orange bottles were 50. Now, what is the probability that Shola will pick a green bottle? We know the total number. We know the number of favorable outcomes. There are 450 green bottles. And of course, we know the total number of possible outcomes. There are 1,000 bottles. So you have 450 divided by 1,000, which is going to give us 0.45. You can see that our probability can either be in fraction or in decimals. And of course, it could also be in percentages as well. The B part to this question says if there are 100 bottles in the container, how many of them are likely to be green? So if there are 100 bottles, since we already know that 450 out of 1,000 will be green, then what if it is 100 and not 1,000? So we just multiply 450 divided by 1,000 times 100, which will give us 45. Or you could simply say 0.45, which we got up here, multiplied by 100 bottles, and that will give you 45 green bottles. The third question says that a vessel contains 4 blue balls, 5 red balls, and 11 white balls. Now if 3 balls are drawn from the vessel at random, what is the probability that the first ball is red, and the second ball is blue, and the third ball is white? Now, the probability to get the first ball as red is 5 out of 20, because there are 5 red balls and there are 20 balls in total. So that will be 5 divided by 20. Now, if you get the red ball and you throw it away, then the number of balls will no longer be 20. It becomes 19. So now, since we have drawn a ball for the first event to occur, then the number of possibilities left for the second event to occur is 20 minus 1, which will be 19. I hope you understand that. The moment you remove one of the balls which was red in the first event and you throw it away, then because they didn't tell us that we replaced it or we returned it. Okay, so if that ball is out, then there are 19 balls left. So if we need for the second ball, if we need a blue ball, there are how many blue balls? 4 blue balls out of 19 balls in total. So that would be 4 over 19, just like we have here. And then because we have removed another one, then the number of possible outcomes has reduced one more time to 18, because we are not told in the question that the ball was returned. So the number of possible outcomes becomes 18. And then we need a white ball. There are 11 white balls out of 18 total balls. So you have 11 over 18. So now, what's the probability of picking them in that order? All right, it means that we picked red and we picked blue, and we picked white. Okay, so hand in probability is multiplication, so we just multiply the individual probabilities together. We'll still deal with this part more and more in subsequent classes, but just keep in mind that when you have hand, that is you did something and you did another one, then it's multiplication. You multiply their probabilities together, and in the case that you have an or, then you add the probabilities together. So if you do that multiplication, you get 0.032, or it can be expressed in percentage as 3.2%. That's multiplying that by 100 will give you 3.2. Okay, so let's look at the fourth question, which will be the last question in this particular class, and then I'll give you an exercise to do. 2 dice are rolled at the same time, I assume. Find the probability that the sum is equal to 1. That's the first question. Second question, the sum is equal to 4, and the third question, the sum is less than 13. Now, if you want to find the probability that the sum will be equal to 1, first you need the sample space. Now, if you roll 2 dice at the same time, then the first die might come up as 1 and the second one come up as 1. So you have 1 and 1. And then, of course, the first can come as 1 and the second comes as 2. Or the first can be 1 and the second is 3. Or the first can be 1 and the second is 4. And down like that until we go through all the possibilities. Okay, until we get to 6 and 6 right here. So if we want to find the sum that is equal to 1, we need to look into our sample space. Is there any of these events that if you add them together, they'll give you 1? There is no such event, because you see the lowest one will be 1,1 here, which will give you addition of 2. It means that such an event cannot happen. It is impossible to roll 2 dice at the same time and get the sum of the outcomes to be equal to 1. So our probability is 0. Remember, we said the probability of 0 means that an event cannot happen. So that is 0. And then next we have to find how what's the probability that the sum could be 4. Now, if you look into your sample space, you can see here that if you have 1 on the first die and 3 on the second die, the sum will be 4. So that's one possibility. Of course, if you have 2 in the first die and 2 in the second die, of course that will give you 4 as well. That's 2 possibilities. And then lastly, if you have 3 in the first and 1 in the second, you also have the same. So there are 3 possibilities where your sum will give you 4, and then that will be 3 divided by the total number of possible events. That will be 36, 6 in 6 places, and then you divide that to the lowest term, you get 1 over 12. I want to believe that what we have done so far is not strange to you. To an extent, you must have a very good idea of these already. Now the last question says, from the sample space, okay, it says we should look for the one that can sum up to 13. And if you look into your sample space, you realize that the highest would be 6 plus 6, which will be 12. So it says that the sum is less than 13. So the highest sum is actually less than 13. It means that all these events will sum up to a value that is less than 13. So just That would be 1. It's an event that is certain to happen. So that's 36 divided by 36, which will give you 1. Okay, so for your assignment, for your exercise, there's a note that accompanies this video that would be on your portal. So what you do is to download that video, and then you check the page 8 download the note and check page 8. You would see there's a link to some questions on quizzes which you are required to do, and please make sure you register with your real names and not nicknames, and more importantly, make sure that you do it before the end of the day. Okay, make sure you do it before the end of the day. In our next class would spend more time in solving questions, and then in moving further in our discussion and understanding of probability. So that would be all for this moment. Have a wonderful time out. I'll see you in class.